Okay, hey everybody, how's everyone doing? All right, I want to thank EMC for putting on this event and all the fabulous food, and for Mass Challenge for hosting it and inviting me to talk to all of you today. So my company, Appsembler, we were in the Mass Challenge class last year. We had just come back to Boston from San Antonio, where we were participating in the Techstars Cloud program. We have some Rackspace people here, I think, yeah. And now we're in the Mozilla Web Forward Accelerator. And a little known fact, we participated in the very first Mass Challenge under a different company. So if you want to ask someone about startup accelerators, I'm your guy, because I've been through 4 of them. This is the only slide with bullet points, I promise. So I thought we'd talk a little bit about me and my company, and I'm going to talk about what is open source and why is it important, and a little bit about what is the open cloud and where are we heading, and then hopefully we'll have time at the end for some Q&A. So when I was in high school, I took all AP classes except for history, because I thought history was boring. You know, it's stuff that's already happened, it's in the past. I want to live in the future. Well, I've changed my thinking about history, and I think we can learn a lot about the future by looking at the past. So you're going to get a dose of history in this talk. This is my first computer. I discovered Linux in college at my university AI lab. It was back in '94, so I'm dating myself. And then right after college, I flew to Denmark, Copenhagen, and I got my first job building a website, because they didn't have a website. Then a few years later, I started working with an open source content management system called Plone. Who's heard of Plone? Wow, great. Hey, Mick. That was when I got the open source bug. I was like, wow, this is really cool. And I got to fly all around Europe going to these developer sprints, these hackathons, and like sit with people and like work on open source software. I thought, this is really great. A few years later, I came back to Boston and I started my own company, a consulting company, not the one I'm doing right now. And we needed a hosting company for our website. And we were one of the first people to try Amazon. Like, this is back before they had EBS. So we were running like cron jobs like every 15 minutes, backing our stuff up to S3. We were like living on the bleeding edge. And then a little bit later, I tried Google App Engine, and I experienced this like one-click deploy to the cloud. It's like, you know, it was just this amazing experience. And so I got the cloud bug. So I started this company to explore those 2 interests. So I want to talk a little bit about kind of the background. So we're all familiar with these popular commercial services. We use them every day. We put lots of data into them, important and often sensitive data. But that makes them not really suitable for the enterprise. Not to mention, we can't really put our company brand on them or customize them to meet our needs. Well, as it turns out, there are open source alternatives to these proprietary services that we can trust and that we can customize. It's not just these big services that we've all heard of. There's also open source is penetrating a whole range of markets, from education to developer tools, you know, to peer-to-peer communication. So this is all great, but there's a problem. So unless you swim in these waters, you probably haven't heard of these open source tools. So this is the problem of discoverability. You can't choose the more secure and flexible open source solution if you don't even know it exists. And even if you've heard of it, most of these open source tools are not offered as a hosted service. Sure, the code is available on GitHub, but it's at rest. What do I mean by that? I mean, the code is potentially useful, but only after it's been downloaded and installed somewhere so you can play with it. Well, you might be technical enough that, to do this yourself, but most likely you're going to have to hire a developer to do it for you, and we all know that developers are expensive and they're hard to find. And even if you have a developer to get this software running for you, it's going to take a lot of time. I can see the resemblance. It's going to take some time to get this software set up, right? And so we conducted a survey of our developers, and we found that of 208 developers, 50% of them spent between 1 and 4 hours to deploy an app, and 17% spent more than 4 hours. That's, you know, it might not seem like a lot, but it adds up. So unless you're a Jedi, you probably aren't going to be able to download, install, and evaluate that open source app fast enough to meet your boss's deadline. So at this point, you will probably resort to using a proprietary SaaS product, or you'll decide that it's better to build than to buy. And if you go with that proprietary SaaS product, there's a huge risk of vendor lock-in. And if you build your own, well, except in very rare circumstances, that's a recipe for disaster. And if you do go with that open source solution, the boss is going to want to know, who do we call when something breaks, right? Where do we host this software, and who do we call, like, who's going to stand behind this product? So that's the world we live in today. And we thought, why does it have to be that way? Why, when faced with this decision between open source and SaaS, is it so hard to choose the open source choice? So we made it really easy to turn any open source web application into a SaaS product. With the same level of professional hosting and support that you'd expect from a proprietary SaaS product. Remember when I said the code is at rest? Well, with Appsembler, we put that code into motion. We wrap it up in a nice package, and we make it really easy to run in the cloud. So instead of taking 4 hours to try out that app, it only takes you 5 minutes.
Wait a minute.
Patriots much?
What's wrong with that?
Yeah, okay. That's the only one they have on the GitHub, you know. I'll put like a, you know, other logo on it. Okay, so that's about that's what I'm doing, but I'm not here to talk about my company. I want to step back and make sure that everyone understands what we mean when we say open source. How does it differ from closed, and why does that matter? So as I was kind of mingling around here, eating calzones and drinking my Sam Adams, I chatted with a few people who were very, very technical. So I apologize if this is, you know, perhaps a little bit, you know, too pedestrian, but bear with me. So we've all heard of the Encyclopedia Britannica, right? This is a closed, proprietary book collection. And Encyclopedia Britannica stopped making its print edition last year. We all know that Wikipedia is going gangbusters. It's open, it's community-generated content. One of the world's highest ranked websites. Has 200 times the number of contributors and over 60 times the number of articles of Encyclopedia Britannica. So it's no wonder that Britannica is going the way of the dodo. So would you buy a car that can only be serviced by the dealer? What if the hood was welded shut? Well, Volvo made a car. The whole front of the car is molded in one piece, which can be removed only by a Volvo mechanic. No, you want to have a choice. You can take your car to different mechanics to get the best service. Or maybe you're a do-it-yourself person, and you want to pop open the hood and service it yourself. So buying proprietary software is kind of like buying a car where the hood is welded shut. It's vendor lock-in. This is a huge risk. With open source software, you have the freedom to go to any vendor and to get that software customized for you. Or if you have some technical chops, you can make those modifications yourself. Okay, for the next example, I need some volunteers.
David.
Kara, come on up. And who else is raising their hand? Matt, come on up. All right, for a second appearance, Matt and Kara. Let's give an applause, Matt and Kara. All right. So last week, I had Kara over for dinner. Not really, but let's just pretend. And for dessert, I served these amazing chocolate chip cookies. Okay, they were so delicious that Kara asked me if she could, get some of these to take home with her. And I told her that not only could she take home the cookies, that I would give her the recipe. The following weekend, Matt here went over to Kara's place for dinner. And she decided to make the cookies for Matt. And but you know, he was. Are you vegan, Matt?
Not yet, no.
Are you gluten intolerant?
Not that I know of.
Are you allergic to nuts?
I like nuts.
Do you just like coconut?
Coconuts are good.
Let's just pretend that you don't like coconut. Okay.
Don't like coconuts.
So Carrie here modified the recipe because she knew he doesn't like coconut. And see, my recipe has coconut in it. So if I had just given Kara the cookies, she couldn't serve them to Matt because he doesn't like coconut. So she was able to customize the cookies to meet the needs of her guests. Thank you all. You may now sit down.
That was nice of you.
Okay, so when you buy proprietary software, you're just buying the cookie, right? The maker doesn't provide the recipe for how the cookie was made. So if you want a vegan version of that cookie, you can't just follow the directions, but substitute coconut oil for butter. You have to go back to the cookie maker and make her submit a request. And you know what they'll tell you? Thank you for your request. If you're lucky. Right, so Matt here was so enamored with Kara's modified cookies that he asked her for the recipe so that he could make them at his home. There was no cost in delivering that recipe, right? The real value came behind the infrastructure of making those cookies, the kitchen, the ingredients, the utensils, the human labor. Notice there's nothing here that prohibits you from selling those cookies. Some people don't want to be bothered with, baking and buying ingredients and doing all that kind of stuff. They just want the final product and let someone else clean it up. And they're willing to pay for that premium of getting those beautiful, tasty cookies delivered to them. But with open source, just as with the cookie recipe, you have the freedom to modify it and share those changes with others. So what does open source mean in the context of the cloud? I'll tell you another story. So this is how products used to get shipped. Humans would manually transport the product, in this case, bananas, off the ship. Well, this is fine when human labor is cheap. But in the 60s, the cost of time at the dock as a percentage of total shipping costs increased from 30% to 75%. So naturally, this created a tremendous incentive to find a way to reduce the cargo handling time. So this is called break bulk cargo. And it's generally handled 4 times. So you have to move the goods from the point of origin, you have to load them onto the ship, you have to unload them, you have to move them from the point of destination, and then third, the goods have to be hand sorted and placed. So San Francisco was locked into doing it this way back in the day. Well, Oakland, nearby, embraced what we call containerization. And within a few years, Oakland surpassed San Francisco as the leading shipping destination on the West Coast. So what lessons can we learn for delivery of software and the virtues of the open cloud? So does anyone know what these are? These are containers, that they allow the entire process to be mechanized, which increase loading and unloading rates from 25 tons per hour to 600 tons per hour. And this dramatically reduced the amount of time spent at port, which lowered the dockage and wordage fees. So just like these standard containers are a fundamental unit of shipping products, so can standard containers be a fundamental unit of software delivery. So there's these standard operations, right? So in the case of a shipping container, you have to lift them, stack, load, label. Similarly, containers in the software world can be started, stopped, copied, snapshotted, downloaded, uploaded, and tagged. Just like shipping containers, standard containers are content agnostic. So all the standard operations have the same effect regardless of the context. A shipping container will be stacked in exactly the same way, whether it contains Vietnamese powder coffee or spare Maserati parts. Similarly, standard containers are started or uploaded the same way whether they contain a Postgres database, a PHP application with its dependencies, an application, or Java build artifacts. Both types of containers are infrastructure agnostic, so they can be transported to thousands of facilities around the world by a wide variety of equipment. So a shipping container can be packed in a factory in the Ukraine, transported by truck to the nearest routing center, stacked onto a train, loaded into a German boat by an Australian-built crane, stored in a warehouse in a US facility. Similarly, a standard container can be bundled on my laptop, uploaded to S3, run and snapshotted by a build server in Virginia, uploaded to 10 staging servers in a homemade OpenStack cluster, and then sent to 30 production instances across 3 EC2 regions. Pretty cool. And because they offer the same standard operations, regardless of content and infrastructure, standard containers, just like their physical counterpart, are extremely well suited for automation. In fact, you could say that automation is their secret weapon. So many things that once required time-consuming and error-prone human effort can now be programmed. Before shipping containers, a bag of powdered coffee was hauled, dragged, dropped, rolled, and stacked by 10 different people in 10 different locations by the time it reached its destination. And 1 out of 50 disappeared. Poof. 1 out of 20 was damaged. The process was slow, it was inefficient, and it cost a fortune. And it was entirely different depending on the facility and the type of goods. So similarly, before standard containers, by the time a software component ran in production, it had been individually built, configured, bundled, documented, patched, rendered, templated, tweaked, and instrumented by 10 different people on 10 different computers. And we all know that builds fail, libraries conflict, mirrors crash, post-it notes were lost, logs were misplaced, and cluster updates were half broken. This process was slow, inefficient, and cost a fortune. And it was entirely different depending on the language and the infrastructure provider. So there are now 17 million shipping containers packed with every kind of physical good imaginable. Every single one of them can load it on the same boats, on the same cranes, in the same facilities, sent anywhere in the world with incredible efficiency. It's embarrassing to think that a 30-ton shipment of coffee can safely travel halfway across the world in less time than it takes a software team to deliver its code from one data center to another sitting 10 miles away. So with standard containers, we can put an end to that embarrassment by making industrial-grade delivery of software a reality. So a unit of software delivery can be called a standard container. And the goal of this is to encapsulate a software component and all of its dependencies in a format that is self-describing and portable, so that any compliant runtime can run it without any extra dependency, regardless of the underlying machine and the contents of the container. So software development is not unlike Legos, right? It's mostly assembly of blocks, or in software terms, components that can be pieced together. So most of the code that I write these days is what I call glue code. So these are code that pieces together components, open source components that I find on GitHub or wherever. And I want to put out the bold claim that open source components are superior to using proprietary components. And by the end of this presentation, I hope you will agree with me, or if you don't agree with me, at least I may have prompted you to question your beliefs. So, this is probably, old news to most of you, but you've all heard of SaaS, right? Software as a service. And infrastructure, IaaS, is another acronym we use when we're referring to hosting providers, Amazon, Rackspace, proprietary. And PaaS sits somewhere in the middle. So the reason it's called a platform as a service is because it provides more than just the low-level infrastructure. It provides the application layer. So here you can see a little more detail. PaaS, this is what's provided by IaaS, and up here you have the operating systems, the runtime, and the middleware. So this is kind of the state of the world. This is by no means an exhaustive list of all the, there's like literally hundreds of these, but these are like, from where I sit, these are kind of like the main ones. So you have these proprietary PaaS providers like Windows, Azure, Heroku, Google App Engine, Amazon Web Services, and then the open source ones, CloudFoundry from VMware, and OpenShift. And there's a few other ones that are not as well known, they're kind of up and coming. And I put .cloud in the middle because .cloud is an interesting one because it started out being over here. And a few weeks ago, they shut down their free tier and they open sourced most of their technology. And I found this really, really interesting. They're using this as a strategic tactic to essentially get more people involved on building their stack. They're putting their Docker technology, which is that whole thing with the shipping containers. I didn't write that. That's all Docker stuff. And what I think what's really cool about .cloud is they're basically taking the Linux container and they're making it portable. I can snapshot my application with all of its dependencies, all of its OS requirements, and I can move that thing anywhere. I can ship it wherever I want. I'm not going to talk about infrastructure as service because there's 2 other speakers after me that are probably going to do a way better job of explaining all that to me. So, the future. Cheryl mentioned that we should talk about some of the trends and some of the things that we can look into the future. And we don't know what's going to happen in the future, but we can look at what's happening right now. So according to IDC, Linux servers generated $2.4 billion in revenue for vendors in the first quarter of 2012. That's a 16% growth rate, which is better than the 1.3% revenue growth rate for Windows servers. Something to think about. This is a study that Black Duck Software did, and they claim that by 2016, 50% of all software purchases will be open source. And the UK government recently mandated a preference for open source software, citing that proprietary products must only be used in rare circumstances. So if you're in the UK, you have to use open source, if you're in the government, that is. This one I just came across today, also from Black Duck. This is looking at Android mobile projects outstripped iOS projects by a factor of 4 in 2012, expanding those in 96% in each year since 2007. So new iOS project growth by comparison was 32% from 2011 to 2012. So to date, over 15,000 new Android mobile phone projects were launched. And compared to iOS, which is only 2,500. So Android is just going through the roof. So we've come a long way from my first personal computer and to this personal computer, which I wear on my head, and it's basically a dumb terminal which is connected to the internet, the cloud. That's where everything lives. So with that, I want to thank you. And open it up for questions.